Hi all, welcome to new class. Today's class is the continuation of network functions, that is the problems related to network functions. So in the previous class we have discussed some problems related to network functions. So let us do an important problem related to the network functions. For the network shown, determine the transfer functions g to 1 of s, z to 1 of s and z1 1 of s. So this is the given circuit diagram. So here there are three loops. So consider this as first loop, then second loop and third loop. So here v1 of s, i1 of s, v2 of s, i2 of s are given. So let the current in the second loop be I3 of s. So consider I3 of s as the current in the second loop. Now apply KVL for loop 1. So while applying loop 1, in the loop 1 we will get V1 of s minus 20 into current through this 20 ohm resistor is I1 of s minus I3 of s equal to 0, or we can rearrange V1 of s equal to 20 I1 of s minus 20 I3 of s. So this is equation 1. Then applying KVL for loop 2. So in the loop 2 it is minus 10 I3 of s, then minus 1 by 2s into current through that capacitor is sum of I2 of s and I3 of s, that is I2 of s plus I3 of s, then minus here I3 of s is in this direction and I1 of s opposite direction, so we can write my plus I1 of s minus I3 of s into 20 equal to 0. Now we can rearrange this equation, that is here 20 I1 of s is there, 20 I1 of s, then here I2 of s, this minus 1 by 2s into I2 of s, then minus 10 I3 of s, then here minus 1 by 2s I3 of s, then here minus 20 I3 of s. So here we can take this minus outside. So into I3 of s equal to 0. So again we can rearrange this one like this, that is minus 20 I1 of s plus 1 by 2s into I2 of s, then plus here 30 plus 1 by 2s into I3 of s equal to 0. So this is the second equation. Now applying KVL for the loop 3, then we will get V2 of s is equal to current through 1 by 2s is I2 of s plus I3 of s. So this is the third equation. And we have I2 of s is equal to 0. So the second equation will be, minus 20 I1 of s plus 30 plus 1 by 2s into I3 of s equal to 0, and equation 3 will be V2 of s is equal to 1 by 2s into I3 of s. Now from this equation we can find the value of I3 of s in terms of I1 of s. That is, from this one we can write I3 of s is equal to 20 divided by 30 plus 1 by 2s into I1 of s, and that is equal to, taking the LCM, we will get here 2s, and that will be in the numerator. So 40s divided by 60s plus 1 into I1 of s. So I3 of s is equal to 40s divided by 60s plus 1 into I1 of s. Now put this value in this equation, that is in the third equation. So we will get V2 of s is equal to 1 by 2s into I3 of s is 40s divided by 60s plus 1 into I1 of s. So here s cancelled and 2 20 times. So we will get 20 divided by 60s plus 1 into I1 of s. That is, from here we can write Z21 of s. Z21 of s is equal to V2 of s divided by I1 of s, and that is equal to 20 divided by 60s plus 1. So this is the value of Z21 of s. Now we have to find G21 of s and Z11 of s. Now put the value of I3 of s in the first equation. So now put the value of I3 of s in this equation. So we will get V1 of s is equal to 20 I1 of s minus 20 into 40 s divided by 60 s plus 1 into I1 of s, and that is equal to, here we will get 800s and here 60s plus 1. So we have to take the LCM. So 20 into this one, that is 1200s plus 20 minus 800s divided by 60s plus 1 into I1 of s. Again we have 400s plus 20 divided by 60s plus 1 into I1 of s. Now we can write the value of Z11 of s, that is V1 of s divided by I1 of s is equal to 400s plus 20 divided by 60s plus 1. So this is the value of Z11 of s. Now we have to find the value of G21 of s. So what is G21 of s? It is V2 of s divided by V1 of s. So V2 of s is here and V1 of s is this one. So G21 of s is the voltage transfer ratio, that is V2 of s divided by V1 of s. V2 of s is 20 divided by 60s plus 1 into I1 of s divided by V1 of s is 400s plus 20 divided by 60s plus 1 into I1 of s. So here 60s get cancelled. So we will get 20 divided by 400s plus 20. Again we can rearrange this one, that is 1 divided by 20s plus 1. So G2 of S is 1 divided by 20S plus 1. So these are the values. So G21 of S, Z21 of S, then Z11 of S. Let us do another problem. For the network shown, determine the following functions: Z11 of S, Y11 of S, G21 of S, and alpha 21 of S. So this is the given circuit, and here these are in time domain. So we have to convert into S domain functions. So redraw the circuit. So this is capacitor and its value is 1 by 2. So in S domain it will be 1 by Cs. So here C is 1 by 2. So here it will be 2 by S. And this is 1 Henry and it will be 1 S or simply S. And here 1 Farad, that is 1 by Cs means it is 1 by S. Then here this is 2 Henry, that is 2S. So these are the transformed values of the given network. Now here these two are in parallel. So we can convert this into single element, that is here we will get S into 2 by S divided by S plus 2 by S. That is we will get 2S divided by S square plus 2. And here also we can convert these two elements into single element. Now redraw the circuit. So these parallel elements are equal to 2s divided by s square plus 2, and these two in series equal to 1 plus 2s square divided by s. Now we can write in the new network. So this is 2s divided by s square plus 2, and this is 1 plus 2s square divided by s. Now we can apply KVL for the loop 1. So here we will get, so this is I1 of S and this is I2 of S. So while applying KVL, we will get V1 of S is equal to I1 of S into 2S divided by S square plus 2. Then here I2 of S is 0. So plus this one, that is 1 plus 2s square divided by s. So this is the first equation. That is, from this one we can write Z11 of s, that is V1 of s divided by I1 of s is equal to this one, and we can rearrange this equation, that is 2s square plus, here we will get s square plus 2 plus 2 s raised to 4 plus 4s square divided by s into s square plus 2, that is equal to 2s raised to 4 plus 7s square plus 2 divided by s into s square plus 2. So this is the value of Z11 of s. Then we will get y1 of s, that is y11 of s is equal to reciprocal of this one, that is s into s square plus 2 divided by 2s raised to 4 plus 7s square plus 2. So this is the value of y11 of s. Now we have to find g21 of s and alpha 21 of s. So for that, apply KVL for the second loop, that is KVL for the loop 2, we will get V2 of S is equal to 1 plus 2S square divided by S into I1 of S. Then what is G21 of S? So G21 of S is equal to V2 of S divided by V1 of S. So V2 of S is this one and V1 of S is this one. So we can write that is this is V1 by I1. So V1 of S is this into I1 of S. So we can divide V2 of S divided by V1 of S. That is 1 plus 2S square divided by S whole divided by this one, that is 2S raised to 4 plus 7S square plus 2 divided by S into S square plus 2. So I1 of S get cancelled and here we can cancel this S and rearrange this one. So we will get, and here this S square plus 2 will be in the numerator, that is 1 plus 2S square into S square plus 2. So G21 of S is equal to 1 plus 2S square into S square plus 2 divided by 2S raised to 4 plus 7S square plus 2. Then next question is alpha 21 of S. So what is alpha 21 of S? Alpha is I2 of S divided by I1 of S, and here I2 of S is 0. So its value is 0 here. So these two are very important problems in network functions. So that is about the problems related to network functions. Thank you for watching the class. If you like the classes, please like, share and subscribe my channel.